Ganymede, the largest moon of Jupiter and the entire Solar System, surpasses the sizes of Mercury and the dwarf planet Pluto, and comes in only slightly smaller than Mars. With an icy surface concealing a salty ocean, the Moon presents the possibility of supporting life. It has now become the primary focus of the European Space Agency's Jupiter Icy Moon Explorer mission, JUICE, which launched on April 14, 2023, at 8:14 a.m. Eastern Daylight Saving Time, 12:14 GMT, and is set to arrive in the vicinity of Jupiter in December 2031. Ganymede is approximately 4.5 billion years old, which is the same age as Jupiter. The third Galilean satellite and seventh moon overall, Ganymede orbits Jupiter at a distance of around 665,000 miles, 1,070 million kilometers. Ganymede orbits Jupiter in about 7 days on Earth. Daytime temperatures on the surface average ranging from -171 degrees Fahrenheit to -297 F, according to NASA. The only magnetosphere-equipped satellite in the Solar System is Ganymede. A magnetosphere is a comet-shaped area that is typically found in planets, such as Earth and Jupiter, where charged particles are confined or refracted. NASA claims that Jupiter's magnetosphere completely encloses Ganymede's magnetosphere. Galileo Galilei made the discovery of Ganymede on January 7, 1610. It was the first moon discovered orbiting a planet other than Earth, together with 3 other Jovian moons. Following Galileo's discovery, it was finally realized that planets orbit the Sun rather than the Earth as the center of our solar system. This moon was known as Jupiter 3 by Galileo. The moon was given the name Ganymede, a Trojan prince from Greek mythology, when the numerical naming system was abandoned in the middle of the 1800s. Ganymede, who had assumed the form of an eagle, was transported to Olympus by Zeus, the Roman mythology's equivalent of Jupiter, where he served as a cupbearer for the Olympian gods and was one of Zeus' lovers. Numerous satellites have passed by Jupiter and its moons. Pioneer 10 initially landed in 1973, and Pioneer 11 followed in 1974. During their flybys, Voyager 1 and Voyager 2 delivered spectacular images. Galileo's spacecraft captured precise photographs of the Galilean moon's surfaces while flying as close as 162 miles, 261 kilometers, above them. 3 moons, Ganymede, Callisto, and Europa, will be examined by the ESA's JUICE mission. Ganymede will be the main focus because it demonstrates how icy worlds evolve and may generally be habitable. Researchers will work to better understand its ocean and icy crust, map its surface in great detail, discover more about the interior, explore the atmosphere, and investigate the magnetic field. The surface of Ganymede is composed of a metallic iron core, a layer of rock, and an extremely thick crust made primarily of ice. The surface of Ganymede also has a number of peaks, which might represent rock formations. NASA's Voyager 1 and Voyager 2 spacecraft, as well as the dedicated Jupiter-orbiting Galileo probe, provided observations for the creation of the first detailed map of Ganymede in photographs and a video animation, which were released in February 2014 by NASA and the United States Geological Survey. Approximately 40% of Ganymede's surface is dark with numerous craters, while 60% of it is lighter in hue with grooves that create intricate patterns to give the satellite its distinctive look. The grooves are as high as 2,000 feet, 610 meters, and extend for thousands of miles. They were probably created as a result of tectonic action or water being discharged from underneath the surface. It's thought that beneath the surface of Ganymede is a saltwater ocean. The auroras on Ganymede were examined by the Hubble Space Telescope in 2015 to see how they varied between Ganymede's and Jupiter's magnetic fields. According to experts at the time, the aurora's rocking provides proof that the ocean beneath is likely saltier than the oceans on Earth. However, some scientists doubt that life may exist on Ganymede. It is thought that the pressure at the bottom of the ocean is so great because of its internal structure that any water would freeze there. This would make it challenging for any hot water vents to deliver nutrients into the ocean, which is one scenario that scientists think could support the existence of extraterrestrial life. Ganymede is larger than Europa, the largest of all moons we have in the solar system. And it is the only moon that develops its own magnetic field in the interior. Only planets and suns or stars have magnetic fields, and Ganymede. It's possible that a specific size is a prerequisite for the internal conditions that permit the operations that generate the magnetic field. The radius of Ganymede, at 1,640 miles, 2,640 kilometers, is 2.5 times smaller than the radius of the Earth, greater than Mercury in size. Its extremely diluted gas envelope is continuously lost, destroyed, and then created from the surface. Because of the low gas density, molecules seldom ever clash with one another. Ganymede consists primarily of silicate rock with an ice shell outside. The ice shell is thicker than Europa's. That is a fascinating query. The distance from Earth would be a crucial factor to know. Assume it would be the same distance from Earth as the Moon. The sky would then appear considerably bigger and much brighter. The area of Ganymede's disk is 2 times larger, and it reflects light approximately 4 times better. So on a full moon night, we would enjoy lighting akin to that of day. Additionally, because its mass is 2 times that of our moon, the ocean tides it would produce are also twice as large.